This is Ham College, episode 83, for November 30th, 2021. This episode of Ham College is brought to you by Icom. This season, spice up your ham shack with Icom's IC705 Portable or the new, now shipping, ID52A handheld. Happy holidays from Icom. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And this is the this is the end of November episode.
Which just happens to be in December.
In early December.
Yeah.
Interesting questions tonight. We're still studying RLC circuits.
Interesting's a good word, I guess.
Yeah, I guess that's the best. What did we talk about last time?
That's a good question. We did talk about some circuits, resonance and Q characteristics of resonant circuits. That was a tongue twister. Series and parallel resistance, resonance. I don't know. I can't even read this thing. Definitions and effects of Q, half power bandwidth, phase relationships, and reactive. Wow. That was a lot to say.
Yeah.
You know what we're going to talk about this time?
It's kind of similar. I think I know.
Some tough stuff.
Yeah. It's going to be time constants and phase relationships, RL and RC time constants, phase angle and reactive circuits and components, and admittance and susceptance.
Yeah, it's easy for you to say.
This is the point where electronics got hard.
Yeah,
when I was studying.
I kind of noticed. I don't remember this this stuff being on here when I took my extra test. It may have been on there back then, but I just do not remember.
I don't remember it either, but
and as usual, I didn't study. So I'm taking one for the team and show you what happens if you don't study for your test before you go take it.
Okay. Well, I had to do some research so that we could explain some of these tonight because, boy, there's some tough ones. They're not really that bad once you've studied them, but before that, oh man, it's tough.
Yeah. So watch the look on my face and you'll see.
Well, anytime we're doing a show live, we've also got a chat room going on at the same time. If you'd like to join in the fun, AmateurLogic.TV/chat. But if you're watching live, it's the YouTube chat. What is the term for the time required for the capacitor in an RC circuit to be charged to 63.2% of the applied voltage or to discharge to 36.8% of the initial voltage? Is it A, an exponential rate of 1?
B, one time constant?
C, one exponential period?
Or D, a time factor of 1? I think I know what this one is, but because I know what the topics were for tonight, one of the topics was time constants. The thing what you read a while ago?
Yeah.
So I'm going with that. B, one time constant. But I
So-
don't know. That's my guess. But otherwise I wouldn't have a clue, honestly.
Well, I'm going to say that's a good answer. Everybody in the chat room is saying it is.
Okay.
And it is. Here, I'll go ahead.
Okay.
Look, we actually bumped
really
fist.
did it.
Yeah,
That might be, we haven't done that in a while.
I know.
You want some hand sanitizer?
Yeah, next time, well, I'll go high, you go low. So, yeah. Top me off there. All right, I've got some explaining to do on this one.
Okay, yeah, that would be good because those are some very specific numbers right there.
Yeah, and it would have been nice if I would have studied this explaining before we actually got to it tonight.
It would have been nice if I had studied the topics too, but then it kind of makes it sort of boring.
Well,
If we both sat here and ripped down through every one and got them all right, it would be kind of boring, wouldn't it?
well, yeah, it could be. This is a view of a series RC capacitor voltage and the time constant. You can see the formula there is time constant equals the resistance times the capacitance. That's a resistance in ohms times the capacitance in farads. Follow along the bottom of the line there. That's the time constant. The first line there, well, after the zero, is one time constant. And if you see as that capacitor is charging up, the slope from zero up to where it crosses the one time constant line hits at 63.2%. The capacitor in an RC circuit does not charge up linearly. You can see there is a slope to it that changes with time. And we call one time constant once it's reached 63.2.
What's the significance of those values? 63.2%. That's a very specific number.
If you took the resistance and multiplied that by the capacitance, one time constant would just happen to work out at 63.2% of the charge. Now, that's if it's a series RC circuit. If it was a series RL circuit, the formula would be different. Time constant will equal L over R.
What letter is commonly used to represent susceptance? A, G,
B, X,
C, Y.
D, B. What letter is commonly used to represent susceptance?
Yeah, this would be another guess right here.
Yeah. Well, I think it would be a guess. I know it wouldn't be X because that's reactance.
Yeah, I wouldn't think it would be Y either, but and I don't know. They're typically used for other things. They're like the first ones they're used for stuff.
Well, the actual one it is, I'm not really seeing them just run off the rails with the answer here in the chat room either. Well, there's a couple answers in there. A few now.
Yeah, they're starting to come in.
Yeah. It is DB.
DB.
Yep. Answer D, which is the letter B. That stands for susceptance. You know what susceptance is?
Nope.
Susceptance is the imaginary part of admittance where the real part is conductance.
This is made up.
That does sound kind of imaginary. I could have
came up with that.
Yeah. The reciprocal of admittance is impedance, where the imaginary part is reactance and the real part is resistance. An SI unit susceptance is measured in Siemens. Or Simons. I don't know how you want to pronounce that. Admittance is a reciprocal of impedance. And impedance that's impeding the flow of current, where admittance would be accepting or admitting the flow of current. Allowing. That's a good word.
Okay.
And, when we're talking about AC here, things get complicated. You're not just dealing with a resistance. You're dealing with a reactance as well, which is the imaginary part. The real part is the resistance. I'm not sure why they use that term imaginary.
Yeah, I'm not either because that kind of really messes with your head a little bit.
Yep. It does.
I can imagine a lot of stuff.
Well, true, but not all of it's right. That's the problem.
Well, is this right?
Well, that's the answer. Let's see. It is. Thanks for bringing that up. I guess it was good to actually get to the point.
Interesting.
Okay, I got another question for you. How is impedance in polar form converted to an equivalent admittance? A, take the reciprocal of the angle and change the sign of the magnitude.
B, take the reciprocal of the magnitude and change the sign of the angle.
C, I'm glad you got this one. Take the square root of the magnitude.
You laughing over there? That's mean, man.
C, take the square root of the magnitude and add 180 degrees to the angle.
Or D, square the magnitude and subtract 90 degrees from the angle. I have no earthly idea. I want so bad to look down at the chat room, but I'm not going to. How is the impedance in polar form converted to an equivalent admittance?
Well, this won't be the answer, but it's just one thing to know about impedance, that it can be specified in polar or rectangular form. Rectangular would be Cartesian. So that means you could have like 10 ohms with a phase angle of negative 120, or 10 ohms negative J whatever, if you converted it. So there's two different ways of specifying the same number. And they're asking about the polar form there, which would be the one that's showing the number of degrees rather than just saying J or the reactance.
I want to go with B. Take the reciprocal of the magnitude.
And change the sign of the angle.
angle.
That's what the people in the chat room are
Take
saying.
the square root of the... Yeah, I'm going to go with that. That's just a guess. Like, I really don't know. It's probably not. Well, if they said it in the chat room, it might be right.
Yeah. I'm going to agree with you.
What is the time constant of a circuit having 220 microfarad capacitors and two 1 megohm resistors all in parallel? A, 55 seconds.
B, 110 seconds.
C, 440 seconds.
Or D, 220 seconds. You're going to have to do some calculating on this one. So let me just show you my figures where I was going through deciding what this is going to be. The first thing you got to do is you've got to get the two capacitors together and the two resistors together and see what the real values of those are going to be.
Right.
This is a circuit we're looking at. 220 microfarads, two of those in parallel, and then the two 1 megohm resistors there. C total equals C1 plus C2, and resistance total equals the reciprocal of R1 plus the reciprocal of R2.
Okay.
Which, if they're both the same, it's just half. That's the easiest way to figure it out. If there's only two resistors, there's another formula you can use, but if it's more than two, then you got to get with these reciprocals here. So I just went ahead and showed that formula. But essentially, your time constant is going to equal the resistance times the capacitance. So if we said 500,000 ohms times 440 microfarads to farads, that'd be 0.00044 equals 220 seconds. So first part, getting your capacitors down to one capacitance and your resistors to one resistance, then just multiply them. What happens to the magnitude of a pure reactance when it is converted to susceptance? A, it is unchanged.
B, the sign is reversed.
C, it is shifted by 90 degrees.
Or D, it becomes a reciprocal. What happens to the magnitude of a pure reactance when it's converted to susceptance? Okay. Well, you actually said this earlier. So, I mean, it would have to be D.
It becomes a reciprocal. If there's no resistance or conductance present, then the magnitude is a reciprocal of reactance. If there had been some resistance there or conductance, then it wouldn't just be the reciprocal. It gets a little more complicated.
What is susceptance? A, the magnetic impedance of a circuit.
B, the ratio of magnetic field to electric field.
C, the imaginary part of admittance.
Or D, a measure of the efficiency of a transformer. What is susceptance? I don't think it's got anything to do with magnetic impedance of a circuit. I don't think it's got anything to do with the ratio of the magnetic field to the electric field.
Pretty sure you answered this earlier too.
Yeah. And it's not the measure of efficiency of a transformer. It's the imaginary part of admittance. Yeah, we did talk about this earlier.
Mm-hmm.
So I'm going to say it's C. Chat room. Yeah.
We got a few C's. There's not a lot of answers popping up in there, but the ones that are in there are C's.
Tom, I'll agree. I kind of remember these concepts too, and yes, they make my brain hurt now just as much as they did.
Yeah, they make mine hurt too.
I was in college taking electronics in the middle 70s. You know how many times I've had to use this since then?
Probably not too many.
You could probably count them on,
no hands.
No more than 2 hands. When I need it, I just pull out the book and get the formula right there.
Mm-hmm.
I don't have them stored in my head. Now, there's a lot of things I don't have stored in my head anymore. Imaginary part of admittance.
And I don't use any of this stuff with my job and the day-to-day things. So I have absolutely no reason to.
Yeah.
And you do this kind of stuff for your living, and you hardly use it.
So. But I can't tell you when the last time I asked my question or questioned myself as to what is the susceptance of that circuit right there.
Who cares?
It just hasn't come up in 30 or 40 years.
Not even over lunch with coworkers?
Nope, it hadn't.
But you need to learn it here.
Yep, you do.
At least you need to understand it.
Well, talking about your head hurting, how would you like to take a break for just a moment so I can load up some more questions?
Sounds great.
Does sound pretty good, doesn't it?
It sounds fantastic.
Happy holidays from Icom. This season, spice up your ham shack with Icom's IC705 portable or the now shipping new ID52A handheld. These radios are perfect for staying in or venturing out and working your favorite bands this winter season. The IC705 is the perfect sidekick and QRP companion. Base station features and functionalities at the tips of your fingers and a portable package covering HF 6 meters, 2 meters, and 70 centimeters. This compact rig weighs in at just over 2 pounds with RF direct sampling for most of the HF band and IF sampling for frequencies above 25 megahertz. 4.3-inch color touchscreen with live band scope and waterfall, 5 watts with battery pack BP272, or 10 watts with external 13.8 volt DC, single sideband CW AM FM, as well as full D-Star functions, micro USB connector, Bluetooth, and wireless LAN connectivity, integrated GPS with antenna and GPS logger, micro SD card slot, included HM243 speaker microphone, and it supports QRP and QRPP operations. ID52A is now shipping. Icom's newest handheld amateur radio is a VHF-UHF dual bander with D-Star and FM dual mode functions. This radio supports conventional FM communications and D-Star simplex, repeater, regional, and worldwide calls over the D-Star Internet Gateway. The ID52A is the first handheld amateur radio with a full-color 2.3-inch waterfall display and the ability to send photos over D-Star with a connected Android device. Other features include wideband receiver with guaranteed range of 144 to 148 and 440 to 450 megahertz. Simultaneously receive VHF-VHF, UHF-UHF, VHF-UHF with dual DV mode. Integrated GPS GLONASS receiver including grid square location, micro SD card slot, micro USB port for data transfer, programming, and charging, and it meets IPX7 waterproof standards. The ID52 is a perfect companion for the ID705. Our family of favorite Icom amateur radios are available this holiday season. The IC9700, IC7300, and IC7610 base stations, and the ID5100A mobile are the perfect gift. It's the most wonderful time of the year to give the gift of Icom. For more information on Icom radios, visit icomamerica.com/amateur. Tommy, what do you say we give away something?
Hey, how about the shirt off my back? Or one like it?
One like it. That
Okay.
sounds better.
All right.
Yeah.
And how about one of these ball caps that look kind of like this?
That would be nice as well.
Yeah. And maybe some other stuff probably get through in there too.
Could
Good
be.
chance.
Get some room in the box
But this is a
left
cool
over.
shirt though.
Mhm.
You got to admit, look just as good when you leave the Hamfest as you do when you're getting there
Yep.
with your bag of goodies and your cap on.
So if somebody would like to win that, what would they do?
Well, you know, the qualifications are pretty stringent. You've got to have a name and you got to have an email address, and that's pretty much it. So if you feel like you meet those qualifications, you can send an email to hamcollege@AmateurLogic.TV. You don't even have to put a note in there. You can if you want to. We love to read them, but just send your name and your name to hamcollege@AmateurLogic.TV, and if you get drawn, somebody from Icom will get in touch with you and get the rest of your information to get your prizes to you.
And we just drew, right before the show tonight, a random winner for this month's contest. And it says, "Hey, Professor and Dean, wanted you to know I got Gordon West Technician book and found and watched you guys on Roku. Found a club giving the test, tested on my birthday, November 4th, 2021, and passed. They digitally sent in my results, and I had my call sign the next day by mid-morning. Now, KO4ULT.
Awesome.
Have no equipment, but I do have a license. Rick Van Trees in Hartsville, Tennessee. Congratulations,
Yeah,
Rick."
congratulations, Rick. And that is absolutely amazing that they can do that fast now.
Yeah. And welcome to the hobby. When I got into hobby, I took the exam, and it was like a month before I had my call sign.
Yeah, same here. I remember checking the mail every day looking for that thing coming.
Yeah.
Now it's all digital, so you don't have to worry about that. It's pretty amazing.
Yeah, it does go much, much quicker. Well, unfortunately, we've got some more questions tonight.
Unfortunately.
What is the phase angle between the voltage across and the current through a series RLC circuit if X sub C is 500 ohms, R is 1 k ohm, and X sub L is 250 ohms? Is it A, 68.2 degrees with the voltage leading the current?
Lord have mercy.
I couldn't have summed it up better myself.
B, 14 degrees with the voltage leading the current.
C, 14 degrees with the voltage lagging the current.
Or D, 68.2 degrees with the voltage lagging the current. I really have no idea. I know it's going to be wrong, so I'm going with A. I just really don't know. I don't know the formula. I don't know.
Okay, let's see.
I don't have anybody's paper to cheat off of. Let's see.
Well, that was pretty
14
loud,
degrees.
wasn't it? Well, you want me to do some splaining?
Yeah, that would be good.
And let me just say, it took me a while to come up with the correct answer on this because of one particular thing I missed in trying to solve it. Let's look at our circuit first. We've got a 1,000 ohm resistor, an inductor that at whatever frequency we're using here would have 250 ohms of reactance, and a capacitor which at the same frequency would have minus 500 ohms of reactance. The first thing you got to do is combine those two reactances together. Add those two together, then what we're going to have is negative 250 ohm capacitive reactance because it'll cancel out the inductor. We won't even see it in the circuit. Then we've got to do some tough stuff. This is a formula we're going to need to use right here. We take the reactance and divide it by the resistance and then get the arc tangent of that. So let's go through the steps. Here's my reasoning right here, and the logic I used are actually the formulas and figures I came up with when I worked this out. First thing you got to do is solve for x, so that's going to be x sub L minus x sub C. If you combine those together, you've got negative 250 ohms. We know we got 1,000 ohms of resistance, so 250 divided by 1,000 gives us 0.25, which will be a negative number. And then we get the arc tangent of that, negative 0.25, and that comes out to 14 degrees. You have to use the arc tangent button on your calculator or a slide rule. It took me like a couple of sessions of trying to go through here and calculate this out before I could ever get it to come up to negative 14 degrees. And I looked at 3 different books. I looked at Gordo's study guide, I looked at the ARRL question book and the ARRL study guide. I tried to follow what they had, and I still couldn't come up with negative 14 degrees. And I watched some videos on YouTube and did a lot of stuff trying to figure out how did they come up with that answer. It hit me, when you're using a scientific calculator, there's going to be a button on there where you can choose whether you're doing in radians or degrees.
Oh.
You've got to put it in degrees.
Oh.
Yeah, and none of those places that I just mentioned gave that tip. So remember that if you're going to take your exam. If you're figuring out phase angles and such, you want to flip your calculator over to the degree mode.
Tom said, have they changed the rules so you can watch YouTube videos now?
No, they haven't, Tom, but let me just say that wouldn't have helped you a bit. Nobody said hit the degree button on your calculator.
Wow.
Wow, yeah. So that took a little, well, it took way longer than it should have to answer it. Just not paying attention. And I don't often use a scientific calculator where I need to go, do my calculating in degrees.
Yeah. Do you even own a real one? I do not.
I don't think I do anymore.
Yeah.
No. Mm-mm. Okay.
But you may want to invest in one if you want to get those right.
Oh, yeah. Yep. Or borrow one.
Mm-hmm.
You can get them cheap these days. Back when I bought one in school, it was like $80, I think.
Mm-hmm. I had to buy one for my son when he was in high school.
Yeah. Next question.
What is the phase angle between the voltage across and the current through a series RLC circuit if XC is 100 ohms, R is 100 ohms, and XL is 75 ohms? A, 14 degrees with the voltage lagging the current.
B, 14 degrees with the voltage leading the current.
C, 76 degrees with the voltage leading the current.
Or D, 76 degrees with the voltage lagging the current. So I'm going to figure this one out the same way we did the last one. First, I've got to solve the reactance. So that is going to be 100 ohms or a negative 100 ohms of capacitive reactance, 75 ohms of inductive reactance. So that's going to give me like, that's minus 25 ohms of reactance. And then 100 ohms of resistance, 25 divided by 100, 0.25, and it's going to be a negative 0.25. We're in degrees, which that's good. All right, let's go to trigonometry here. And which one is the arctangent there?
Tom says click second, then click tan 1.
He's right. Trigonometry, second, and arctangent. And you got 14. And that was a negative number, so it's a negative 14. I'm glad Tom was handy there. Yeah, that's
So
some
there
tough
you go.
stuff.
Learning moment right there for everybody.
Yeah,
Except
let's just
Tom.
see. So I said it was a negative 14 degrees.
Mm-hmm.
Negative 14 degrees with voltage lagging the current. Oh, I didn't say the lagging part. Since it was negative, that means it was lagging. There's the circuit. First thing we did is we resolved out the reactance would be. That was going to be minus 25 ohms. Minus 25 divided by the resistance 100 ohms. That was going to be a minus 0.25. Take the arctangent of that. Suggestion here is going to be study your calculator before you go. Now, they're not going to let you bring your Windows PC in and use that. So hopefully you won't have a second button you've got to deal with. You'll just have them all, or however your calculator does it. It could be different. What is the relationship between the AC current through a capacitor and the voltage across a capacitor? A, voltage and current are in phase.
B, voltage and current are 180 degrees out of phase.
C, voltage leads current by 90 degrees.
Or D, the current leads the voltage by 90 degrees. What is the relationship between the AC current through a capacitor and the voltage across a capacitor? I'm going to guess it's B.
Okay.
Voltage and current are 180 degrees.
All right. B.
Between the current. That's my guess, but I really don't know. I'm thinking that's
the chat room is saying
right.
D, and I'm going to agree with them.
D. I said D, not B.
Oh, I misunderstood you. I'm sorry.
Okay.
I'd already sounded the buzzer by then.
You got some explaining there, Mr. Wizard?
No, I mean, I don't know how you can explain this other than
that makes two of us.
in an AC circuit, current flowing through a capacitor, the relationship between the current and the voltage is going to be the current leads the voltage by 90 degrees. There's no other way to explain that.
It's just known fact.
Well,
everybody knew it but me.
No, it's not always known, but yeah, if you knew it, there's your answer.
And if you didn't, now you do.
Yep.
You're welcome.
These are quite painful tonight.
You're telling me.
I mean,
you hadn't got a buzzer yet.
If you had been studying this stuff, you could have just rattled all this off, but not. I mean, if you're just coming out of the blue into it, these are tough. Based on that, I think maybe we should take another quick break, and I should load up a couple more questions. I need
something to drink. More questions?
Only a couple.
Okay.
Around the 15th of each month, it's Amateur Radio's original and longest-running video podcast, AmateurLogic.TV, with hosts George Thomas, Tommy Martin, Emil Diodene, and Mike Morneau. Roughly, here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas.
I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
That
That explains a lot. Now we can take this and put it over inside our box. It's flush to the bottom. If we were to rotate, we can see that thing goes all the way through. So we'll have a hole in the bottom.
What ammunition do you use in there?
Actually, you can use black powder. You can use WD-40. You can use, anything combustible. You just have to use the right quantity, and we assume no responsibility for mishaps.
Here's what it looks like after I've got them all soldered together and heat shrinked up. Okay, let's give it a try and see how it worked out. So there you have it, the hula loop. No, you can't null out the dogs barking.
I have 2 thin film solar cells to run this. Looks like a little mini weather satellite, actually. And I'm using guitar string for the antennas.
I particularly like that last one there, $29.99. You can get a 50-foot garden hose extension cord combo.
Do not get cord wet.
Now, most of these J-poles are built with metal elements or tubing. The reason I chose wire for this one is the length of this particular one. So I wanted to hang it from the tree so I can hoist it up there.
Yeah.
Go fishing.
We couldn't find the reel.
Yeah.
Is that what that is?
All right, Tommy, sing the theme song here. The next episode live stream will be on December 17th.
Yep, as of now. Should be.
Mm-hmm. And it's going to be a special Christmas show. So, drop in there. I think there's going to be some interesting things.
What is the phase angle between the voltage across and the current through a series RLC circuit if XC is 25 ohms, R is 100 ohms, and XL is 50 ohms? A, 14 degrees with the voltage lagging the current.
B, 14 degrees with the voltage leading the current.
C, 76 degrees with the voltage lagging the current.
Or D, 76 degrees with the voltage leading the current. Okay. So this is essentially the same question we had earlier. It's different.
Different values.
Different values. But we're still going to need a calculator for it. And it just so happens, I happen to have a calculator right here.
And you have some recent experience in using one.
What values were we dealing with? Let's see. The X sub C is 25. X sub L is 50 ohms. So I'll subtract 25 ohms of capacitive reactance from the inductive reactance. That's going to give me a plus 25 for the reactance.
Okay.
So I'll take the reactance, which is 25, divided by 100. Click on equals 0.25. It's positive this time. It's not negative.
Mm-hmm.
All right. So trigonometry, and let's go to the second here, and we'll choose arctangent. 14, but that's a plus 14. It's not negative this time because we have inductive reactance instead of capacitive reactance. 14 degrees with the voltage leading the current. That's the answer right there. It's going to be B.
That's what everybody else is saying, too.
Would you concur?
Oh, yeah. That's B for sure.
Anybody should know that, huh?
Yeah.
Well, all right, well, let's see. It is B.
Of course it is. What else could it be? B.
Or not to be. Let's just look through the slides since I got them. Well, you know how to get the reactance. You just take the 50 ohms and the minus 25 ohms of reactances, put them together, plus 25. Same formula we've been using earlier. There's everything all ciphered out. Come out with a positive 14 degrees. You look startled.
Yeah, I was just reading it.
What is admittance? A, the inverse of impedance.
B, the term for the gain of a field effect transistor.
C, the turns ratio of a transformer.
Or D, the inverse of Q factor. And I believe admittance would be the inverse of impedance.
Why would you say such a thing?
Well, because, just I went to Ham College, man.
Oh, well,
And
that
I
explains
learned
a
it,
lot.
I learned it in class recently,
Okay.
very recently.
Well, I can't argue with that logic. Well, they're a little mixed in the chat room. Most of the people are
Come
saying,
on, you guys
hey,
got to be Ham College graduates.
No. I'm going to agree with you.
Okay.
I'm going to say it's A. And it is. The inverse of impedance.
So how many buzzers did I get tonight? I know I got one,
2.
maybe 2.
Yeah.
Well, it could have been a lot worse.
Let me say, when I was going through all of these, when I made the images up and all of that earlier in the week, there was more than 2 buzzers going off, but I had to answer all of them incorrectly. No, not incorrectly, but I had to go through all of them because I always check myself. I don't just look straight at the answer and try to figure out how in the heck I'm going to explain that. Sometimes that works out. Sometimes, well, you see how it works out. But, yeah, these were tougher ones. I know last month we talked about how tough the questions were.
Oh, yeah. I didn't think they could be any worse.
They were.
Yeah, I noticed.
They can actually get worse than this, but I have not looked at what's going to be on next month.
It's best just to not even look yet.
Yeah, we got Christmas coming up and all. We don't,
Yeah.
we don't want to go there.
Yeah, we got New Year's coming up, too.
We do. Are we going to do a live stream for New
You
Year's?
just took the words right out of my mouth. I was going to ask you the same thing.
I don't know.
I'm thinking there's probably a good possibility.
Well, let's ask the folks over in the chat room. Chat room, what do you think? Should we do a New Year's live stream this year? Would anybody watch?
Well, I'm pretty sure at least one in there would watch because we were talking about it on the phone.
Oh,
Andy.
I bet. Okay, Andy.
Yeah.
Well, somehow it got real quiet in the chat room there. Okay, now they're answering.
Yeah, I think we must have a pretty good bit of latency on the feed tonight.
It was, yeah, it could be. It was set for ultra low latency. I usually do that for the Ham College episodes. Well, let's check with email and Mike. I'm going to say, yeah, it's going to be a go.
Yep, sounds good.
Will there be party favors? Good question, Johnny.
You'll just have to kind of look around and see if you can find some.
Yeah, we don't know what it'll be because we haven't really talked about it yet.
Yeah. That's kind of how we do a lot of stuff.
Yeah. Wait till the last minute and
No.
Sometimes.
Yeah, not always, not everything.
Marty is throwing his vote for Half Speed Theater in there. I am
That's
too,
kind
Marty.
of an expectation, I think.
Yeah, it is.
I've got a clip that I've been saving for quite some time for that.
Oh, really? Okay.
I'm not going to let the cat out of the bag.
Okay. All right. Well, yeah, it's kind of become an expectation. And now the first group of those were so good. We have to do some looking to come up with good ones for the future.
Oh, yeah. But it's pretty funny stuff, though.
Yeah. They could probably use a lot of stuff out of tonight's episode, though.
I'm going to try to forget this when that actually happened.
It might be a good.
Actually, I'm
idea.
not, because it's kind of painful, but I actually learned some stuff tonight. So that's what it's all about, right?
Yep. Jim said, poor cat. Let the cat out of the bag. Me to show the clip of blood draining out of Tommy's face at the beginning.
Yeah, when we had the pile up, that was crazy, man.
Oh, yeah.
There were so many people at one time on digital, and you can't get in and tell people to hold on. You just have to let it run its course.
Yep. It's been a fun, interesting show tonight.
It has.
I wish I would have taken the few minutes ahead of the show tonight to just review my materials there and my operation of the calculator.
Yeah, well, the material went pretty good. The calculator could have been a little bit smoother, but I couldn't operate it for that either.
Oh,
I haven't looked at that stuff in so long.
I could nail it now, as long as it was questions on series RLC circuits and voltage, leading current, or vice versa.
Yeah, it's pretty interesting.
Some of that gets kind of tough, and these seriously. Those were easy formulas there.
Mm-hmm.
I mean, there are some whoppers when you really get into complex circuits. Hopefully we won't have to do that.
Yeah, I don't remember. Not for the test, I don't think.
Yeah. Well, it's been nice weather here in Mississippi this week.
It has.
T-shirt weather.
Yeah, it's last week was kind of cold, but this week's been really nice.
Mm-hmm.
It's almost summertime again. So I'm hoping tomorrow's nice too.
So what if you had to prepare for all seasons?
Well, I don't. The weather changes so dramatically. You could need a jacket, T-shirts, whatever. You could go to a certain place right there, shop.spreadshirt.com/AmateurLogic. You can get, if it's sunny, you can get a hat to keep the sun out of your eyes. If you're thirsty, you can get a cup for something cold to drink. If it's cold, you can put something warm in there. Jackets, backpacks, there's all kind of stuff in there. Amateur Logic and Ham College swag. So it's about time to get the rest of those Christmas presents wrapped up. So go check out shop.spreadshirt.com/AmateurLogic and finish up your Christmas shopping.
It's an excellent idea.
It is.
Yeah.
I'm going to get my wife something from there.
We're not going to suggest.
Y'all see me at the New Year's thing with the black eye.
I can't really recommend that now, but Marty could,
Yeah.
Mm-hmm.
Actually, my wife's a ham.
Your wife is a ham.
Yeah.
She probably still wouldn't appreciate
No, she would not.
an AmateurLogic ball cap, though.
Actually, you know what? She'd not the ball cap, but she'd probably wear the T-shirt. So
Yeah. What's going to be going on Tuesday night?
Oh man, Tuesday nights. That's one of the best nights of the week. Join us for the Amateur Logic Soundcheck Net every Tuesday night, 8 Central Time or 0200 UTC. We've got all these different digital modes all connected together. It's a lot of fun.
Yep. And if you'd like to get in on the high society or fraternities at Ham College, there's a place you can do that. That is facebook.com/group/Ham College.
Yeah, we're also on Twitter. Follow us at Ham College.
Or
groups.io/G/AmateurLogic. And we're also on MeWe.
MeWe.com/join/Ham College. So, to be honest, probably all of these addresses at AmateurLogic are going to be more activity there than Ham College, but we have both.
But we monitor both.
Yep.
Some of them are the same one.
Yep. And you can get the show note wiki to find out what was in each episode at AmateurLogic.TV/wiki.
Yep.
How was Thanksgiving?
It was great. I actually cooked Thanksgiving this year at my house, and everyone survived, I'm happy to say.
Okay.
So it came out exceptionally well.
Well, we ordered the honey baked ham, and she got their turkey at the same time.
Mm-hmm.
I'm not a fan of honey baked turkey. I've just got to say that.
Oh, is it sweet?
Yeah.
Never had it.
Nah.
No, but the honey baked ham is great.
Yeah. Well, yeah, the ham is great. We ate every bit of that.
We got a Cajun turkey this year.
And the dogs enjoyed the turkey. I wish we had gotten a Cajun turkey. That's what I've gotten in years past, but this year the place we got it from didn't didn't do it.
Yeah,
So.
but my work always gives us a card for Logan Farms, and I got the Cajun turkey. And actually, I just got my card for Christmas today. It came in the mail, so we'll get something for Christmas. Luckily, I didn't have to cook a turkey because we got one for free.
Cajun fried turkey?
No, I think it was smoked.
Okay.
But it had the Cajun seasoning injected in it. It was really good.
Oh, yeah.
Excellent.
Oh, we've had the fried mild seasoned Cajun for the last several years, and oh man, best turkey I've ever had.
Yeah, I fry them. Well, we used to fry them, but it's a lot of work.
And dangerous.
It's it can if you're not careful. But we never had any incidents like that with it. But the cleanup is a pain. It takes you 45 minutes to fry the turkey, and it takes you 3 or 4 hours to clean up the mess afterwards.
Oh, yeah. That makes it less attractive.
Yeah.
Well, thanks for being with us tonight, everyone. Glad you could join us live. And, if you are watching live, you'll want to join in the chat room there, because there's a good time going in there always. And you have to subscribe to Amateur Logic to join the chat. Just that was the only way we could really moderate it.
Yeah, it's we were getting a lot of spam in the Facebook chat, and that pretty much cut it all out, which was great.
Yeah. Any final thoughts before we get out of here?
No, we will see you guys in a couple weeks for the Amateur Logic. See some of you, hopefully all of you, for the Amateur Logic Christmas show.
Yeah, looking forward to it. It's always a fun time.
Oh, yeah, it is. I can't wait to see what we're going to do.
Me either. 7-3, everyone.
73.
If you want to do the if you want to do the coin toss and decide who's going to take the first question tonight.
All right. I don't think I even have any coins. I don't even carry money anymore. I have to flip my debit card.
How is impedance? I just noticed.
Huh?
Tom said, Andy, I think their answer is just trust us. A minus 0.25, take the arctangle of that, arctangent of that.
Well, tangle seems pretty
degrees.
appropriate.